about these other things, because then we can, create these little
Yeah.
snippets.
Yeah. So I'm getting into doing some automation stuff for companies, for even just if you're thinking like clothing, brick and mortar clothing, anything. So it's these back end automations using either Zapier or Make.com, and it's no code. It's a no code platform. It's really straightforward. It's intuitive. I find Make.com, you get better bang for your buck. Both have a free tier that you can mess around with too. So really good for automating podcasting deliveries, automating your sales process, anything. It's crazy. It's awesome.
So you're talking about Make.com and Zapier. What are the types of things that you have been automating or helping other people automate? Just to give us an example.
Yeah. So anything when they get on their landing page, if they get a new contact on their landing page, it'll automatically put it into, say, Airtable or a Zapier table, and then it can automatically write an email to them. There's a whole bunch of different things. For me, I've just started doing it, looking at it for me. But what I want to do is, because I post an article almost every day on LinkedIn, so what I want to do is I want to automate that process as well. So I write it, it posts to LinkedIn, it posts to X, it posts to all these automatically. So it integrates with backend APIs. If it doesn't have an integration into an API, you can well, if you have the background, you can pretty much figure it out yourself and build it in. So it has its own. You can add your own kind of API integration.
I'm going to have to take a look at it and see if I can automate any of my current workload with it. You mentioned the stuff I do with the podcast and whatnot, so that'd be great.
And your newsletter that you send out, you can automate that. You can automatically write it based on some content and then just edit it. The great thing is just automating a lot of processes. It's getting you to a point where you just, if it's emails, you just have to edit something as opposed to writing it from scratch. It's really, really cool. So it integrates with all of the what?
But I mean, we all have our AI tools. Like I use ChatGPT to anything I need a decent structure for. I'll throw it into ChatGPT and say, okay, here are the 4 or 6 things I want to highlight in my newsletter, draft up something quickly, and then I'll go edit it. But I need to tell it, like, these are the 3 podcast episodes I want you to promote. These are the events, and these are details about these events. And, make it look nice. And so are we going to get a lot of benefit of, these automation tools if I'm already using most of that?
Yes.
All right.
It's more along the lines of automating intake and output, if that makes sense.
Intake and outtake. What do you mean by that?
Like input and output. So it automates if you've integrated it into your website and people are signing up for things. So it'll automatically put them into a database. It can create and parse different information. It can categorize people automatically, different things like that based on questions that they answer, and come up with a follow-up plan. It can automatically follow up with people based on previous emails and write those follow-ups. It can. So if you create, this is what I'm going to do. I've got a whole bunch of articles that I want to post about. So what I can do is I can write those articles, put them in a Google Sheet, and then create a schedule to post those articles automatically for me.
All right, that's fairly easy enough, though. But I use Hootsuite and other things to do that.
Oh, yeah.
So I want to take a look at what it's actually going to cut out of my, because I have tools for a lot of these things. If you don't have tools for a lot of these things, I can easily see, when someone signs into my website, they automatically get added to my newsletter list because of my CRM tools that I use.
Yeah, but you're a tech guy. You're more ahead of a lot of these things. But they're like, we can certainly explore together and see where there's some things. But it's more for the people. It's more for like manufacturers or people in the sales realm who don't have access to a lot of the tools, who just want to automate their processes and things like that. So it's pretty much unlimited as far as what you can automate. So, but we can explore it in another talk for sure.
Absolutely. And I want to take a look at it and see what it can do. There's a lot of things.
Workflows, automating workflows, right?
And I want to automate a lot of workflows, but I have tools to do some of that now. I just have to finalize, whatever steps or buy the next version of it or whatnot. But I like to take a look at some of these tools.
Yeah.
We might as well get into it. We've got a few people watching already. Thanks for watching. Welcome back to Futuretech, your weekly source for the latest in tech, innovation, and business. I'm the startup coach, and with me, as always, is my co-host, John Irwin. How you doing today, John?
I'm good. How are you, Craig?
I'm doing wonderful. We've got a lot to talk about today, and I think the first thing we're going to talk about is how sonic waves speed up the brewing process. How does that work?
Yeah, so this is really cool, and that's for later. So researchers at UNSW, what they've developed, and don't think of a reactor like nuclear reactor, but they developed an ultrasonic reactor. And what it can do is it can cold brew coffee in 3 minutes instead of 12 to 24 hours. Now, I didn't know that it took that long to cold brew coffee. I thought it was just you brew it cold or you brew it over ice and it's ready to drink. But apparently, no, I'm totally wrong. So what they've done is they've adopted a Breville espresso machine with a patented sound transmission system. So they've got transducers in there that generate high frequency sound waves of, I think it's around 38 kilohertz through the brewing basket. And so if you guys are picturing it, yeah. So this is for those that the ones that the baristas use at Starbucks and things like that, where you grind your coffee and you tamp it down. That's what this machine. It's not for like the DeLonghi's or the Jura machines that automatically do everything within the machine. So obviously they can probably come up with something like that. So the acoustic cavitation from the ultrasonic waves create microjets that fracture the coffee grounds. So the high frequency acoustic waves, what they do is they induce the formation of violent collapse of tiny bubbles. So the collapsing of those bubbles generate shock waves and high-speed microjets. And these microjets impinge on the coffee grounds, which they fracture them to expose more of their surface area. And so the mixing action also helps disperse the grounds in the water, improving content. And so just a little bit more about cavitation. Cavitation provides a turbulent and shear force that enhance mass transfer of solubles from the grounds. It intensifies extraction of flavor and aroma compounds, which is what you need for a cold brew, which helps to make it far faster than currently passive steeping. So, yeah, the ultrasonic cold brew doubled the extraction yield and caffeine content versus unsonicated coffee. So that's a really cool thing. So really interesting technology, kind of something that fixing a problem that you didn't know that you had. I guess this is great because people who love their cold brew coffee don't have to wait 24 hours anymore.
Yeah, I mean, I have done cold brew coffee before, and it's funny especially when you're first starting, it's hit or miss. And when you're waiting 24 plus hours to determine whether you got a good batch or not, it's a pain in the butt. And then you're like, this didn't quite, I need a little more coffee or a little less this or that when you're doing it. It's interesting that we can now do it in 3 minutes. And it says here that it can be adapted to existing espresso machines, which is nice because I guess maybe you just replace that stamper. Is that what you call it? Whatever this is?
The portafilter.
Oh, it's a portafilter. Okay. The stamper is, I guess, the thing
the tamper, the tamper. I think you would have to get a new portafilter with the horn and transducer. Yeah, where you're seeing there now. Yeah. So the filter basket. So the thing is, I don't know, is if we're looking at this diagram, does it just magnetically attach onto the side of the portafilter? It can't go through it, right? Because then it would block the grounds. So it looks like yeah, it's interesting to see. But there's the transducer. It probably sends the waves through the horn, which sends it through the coffee grounds as you're brewing.
Yeah, and it looked interesting. We were playing a little video there that kind of showed some of the stuff, but most of it was the person talking, so you didn't get to see it really. How exactly do the sound waves speed up the process? Like, what is the chemical reaction to say that, changes from 24 hours to 3 minutes?
Yeah, so getting into a little bit more detail into that. So these are high frequency sound waves. And what they do is they induce the formation of tiny bubbles in the coffee water mixture as it's brewing. And then what happens is these bubbles grow over multiple sound wave cycles, and then they eventually become unstable and violently collapse. And so the bubble collapse, it results in micro shock waves and high-speed jets of liquid impinging on the coffee grounds. And the agitation and impacts fracture the solid coffee particles, which increase their surface area exposed to the water, which is what you want. So the mixing also helps disperse the grounds uniformly, which improve contact with the solvent. And the violent collapse of the bubbles, it generates turbulence that enhance diffusion and mass transfer of coffee solubles into the water. So the energy the sound energy accelerates extraction by intensely mixing on a microscopic scale, not quantum scale, and fracturing the coffee particles themselves, which intensifies the coffee water interaction, which helps for faster steeping.
And I guess this leads to on-demand cold brew, where, rather than having to brew it 24 hours, being a person who spends a lot of time in a coffee shop, like if you haven't watched them do it, they just dump a whole bunch of coffee in a big bucket, literally a big bucket, and they fill it full of water, and 24 hours later they filter it out, and that you got your coffee.
Yeah.
It's fun, like you see this at Starbucks and all these places. That's how they do it. So it'd be nice to do this on demand. So
yeah,
I'm concerned about this part here that says, talks about their sensory analysis and send it to I guess this is in Australia, so the Queensland Alliance for Agriculture and Food, for a sensory analysis. I guess that's a taste and smell test. So 3 samples were sent: a cold brew sonicated at room temperature for 1 minute. The second was sonicated for 3 minutes, and the third was a regular 24-hour steeped at 4 degrees Celsius without sonication. So the research evaluated the example of the aroma, texture, flavor, aftertaste, and attributes. They found that the 3-minute sample provided a similar dark chocolate aroma and aroma intensity to the 24-hour cold brew, but slightly more bitter.
Yeah.
So I'm a little concerned that it doesn't say it tasted better, because
I know. And so based on some of the preliminary research I did, the problem that they have to overcome, it's just obviously a hurdle, is in the fact that they need to figure out the right amount of time to the right amount of time to expose this to the ultrasonic waves. Because yes, there's the overbrewing problem that they seems to be happening with this extraction method.
Yeah, and the reason people do the cold brew is to remove the bitterness of the coffee, right? That's the whole. And so if it's more bitter, you gotta wonder, we want to get to the point where connoisseurs are saying, yeah, this is actually better, versus, hey, it's not as good, so I'd rather have the 24 hours. Because are your cafes going to say, we're going to go to this product that's not as good?
Yeah.
Or, you know what I mean?
Yeah. Like the thing is all they need to do, I think, and maybe they can't optimize it, but they need to optimize the timing and power of the ultrasonic process to prevent the over extraction and the bitterness. Maybe so. The flip side of this is maybe there is no optimal power and timing for this. Maybe doing it faster, you're always going to get some bitterness. Who knows? But it's cool for those that aren't real true coffee connoisseurs and do like triples in their cold brew. That'll be great for them.
So are there other downsides besides, maybe the slightly more bitter, as we mentioned, to using this versus traditional cold brewing?
Yeah, so right now it requires like a more expensive and complex equipment instead of simple steeping. Like you said, you just throw grounds into a big pot. Scaling up batch size may be challenging. It obviously, we're talking about over extraction and subcompounds. The rapid process provides less time for the subtle flavor development over hours, which is why maybe this might not be the best solution, but who knows, it might. The other thing is uneven ultrasonic wave distribution could create inconsistent extractions. The intense process may strip aromatics and alter the mouth feel. There could be metal contamination that could occur. The high frequency sound itself is not audible, but inaudible ultrasound at high decibels may present health risks. You never know. So they're going to have to do more testing on this for sure.
Now, we looked at it, said we could adapt existing machines, and I'm a little leery of that based on some of the things you just said. I would rather have at least a whole mechanism that was being blasted by sonic prepared for this purpose rather than it being adapted by the, metal leakage and a few other things that you talked about that could happen because, this may be the equipment or the people or the environment isn't ready for it. But how difficult do you think it would be to adapt these existing machines?
Yeah, so I don't think it's going to be too difficult since they modified a Breville espresso machine. The only thing is that the transducer and the horn are going to need to be properly designed and tuned for each portafilter. So there's a couple things. The stainless steel parts they have to be able to withstand corrosion from prolonged ultrasonication. There has to be tight coupling to the brewing basket. They're going to have to obviously come up with some custom control software for this. And some mechanism to suppress the standing waves may be needed to distribute the energy evenly. But again, all these challenges, they're just not simple engineering problems, but they're engineering problems that are solvable. Based on what they're doing now without having to fully redesign the espresso machines.
And it says here the new setup has the capability to double the extraction yield and caffeine concentration compared to unsonicated samples. That's definitely a plus for some people.
Yeah, maybe that's the route they go. So it's a little bit more bitter, but you get more caffeine content out of it.
Okay, here comes the obvious question that I always ask. When are we going to see either a fitted module, a complete unit that's all this way, or a kit to adapt an existing unit?
Yeah, so as we can see, like based on the video and the pictures, the technology is still in the early research stage. It's only been demonstrated at the lab scale. So I'm guessing commercialization will take a few more years. Now, not as long as 10 years. I'm guessing 3 to 5 because, and it could be even quicker if they get like Breville or DeLonghi or someone on board and partner with them to continue with the development. And because obviously Breville probably has a lot of experience in designing their machines, which they could bring to the table. So the companies will need to optimize and engineer the technology into consumer appliance form. So maybe 3 to 5 years. But the thing is the safety testing, regulatory approvals, because you're not just building a new espresso machine. You're building a new espresso machine with ultrasonic waves. So think of it like building the first microwave kind of thing, right? So although they're not as damaging, we don't know what the impact could be long term and things like that. So I'm guessing the other thing too is it took them 4 years to get from initial idea to a published paper. So I guess maybe if I'm going to take a guess, you know what? I'd say maybe 5 to 10 years before it becomes mainstream. Again, all these 5 to 10 years. So we're going to have to revisit all of these and go back 5 to 10 years from now and see how accurate I am.
Yeah, and we had a comment here, coffee delivered faster, like a microwave for coffee, just as you were mentioning, it's like a microwave.
Yeah, exactly.
Okay, that's great. 5 to 10 years, typical answer. Are there any health concerns with ingesting coffee? Like it says, it literally changes the structure of it. So, now we're ingesting coffee that was created using these high frequency sound waves. Is there health concerns? Do we need to test?
Yeah, so the ultrasonic waves themselves, they're inaudible, but can cause damage at high intensities. But the units are sealed. So apparently the ultrasound does not directly contact customers. There could be leaching of metals like aluminum or stainless steel into the coffee from the ultrasonic reactor. There could be pulsable leaching of plasticizers or other chemicals from tubing components. There's high localized heat and pressures from acoustic cavitation that could theoretically, like you said, produce new compounds not found in conventional coffee. The rapid extraction may pull out higher levels of undesirable or toxic compounds, like polyphenols and things like that. So the micro aeration of the coffee during the ultrasonication may elevate oxidation and rancidity over shelf life. So, and byproducts, we don't know what the byproducts could be. So there's a lot. There's a lot of safety concerns, even in this brewing, even in brewing coffee, right? That we have to look into.
Yeah. Having said that, would you say that the 5 to 10 years is still standing? Are they going to force these health tests before, or are they just going to put it out and we'll see?
For sure. The reason 5 to 10 is reasonable because it's not like they're developing a new process. It's not like we're talking theoretical. Like if they've got this prototype built, they're doing it. It's just a matter. They've got the instruments to measure all of this stuff. It's just a matter of running through the test, doing it multiple times, and different things like that. Like we talked about earlier, the challenges are not challenges that new engineering needs to be developed for, right? It's regular engineering that just needs to be applied to this, and then knowing that it's regular instruments and devices to measure things that just need to be used properly, calibrated properly, and tested.
Any last words before we move on?
No, it's really cool. I like this article. It's a little future tech, but it's future tech as it relates to what everyone drinks almost every day is coffee. So I like it.
And speaking of coffee,
yeah,
scientists have discovered an amazing practical use for leftover coffee grounds.
So let's dive right into this. So as it feeds into this, those coffee grounds from all of the testing and all of the brewing could be used in this. So just to put things into perspective, annual global coffee production generates over 10 billion with a B kilograms of waste coffee grounds that pretty much typically end up in landfills unless people are using it as fertilizer or whatever in their gardening. So the other thing is concrete production is also very resource intensive. It relies heavily on sand mining, which damages river ecosystems. So researchers pyrolyzed used coffee grounds at 350 degrees Celsius to produce porous biochar particles. So adding the coffee-derived biochar to the concrete increased its strength by up to 30% in testing. Biochar bonds with the cement matrix, so that's how it does, and it acts as a reinforcement filler material, which is really cool. The strength improves as more coffee grounds are added up to a saturation point of around 5% by weight. So what pyrolysis does is it transforms the organic compounds in coffee grounds, so they integrate into the weakened concrete they integrate into the concrete instead of weaken it, so they kind of mix in and help to strengthen it. And the heating occurs in an oxygen limited environment, so the biomass does not combust. And at temperatures around 350 degrees Celsius, the organic compounds break down into biochar and pyrolysis oils and gases. If they were to use higher temperatures above 500 degrees Celsius, it would reduce the yield and weaken the bonding potential. So there's going to be optimizations needed to maximize both the quantity and quality of the biochar produced. Coffee concrete, again, could reduce landfill waste, sand mining impacts, carbon emissions, all simultaneously. But real world performance and durability are going to need further evaluation, especially under like freeze thaw cycles, corrosion, different things like that.
So I was sharing a few things while you were talking about it, including the Wikipedia article on how pyrolysis works. Pyrolysis. so people could see that while you were talking. So how have they figured out how it makes it stronger?
Yeah, that's a great question. It makes it stronger due to a few key factors. So because the coffee grounds are first pyrolyzed into a carbon-rich charcoal called biochar. So it's charcoal. So the biochar itself has a porous structure that provides nucleation sites for the precipitation and growth of the cement hydration products. So the cement itself, the cement hydrates can crystallize and integrate around the biochar, improving the microstructure. And so the biochar also acts as a filter material that can reduce the porosity and voids within the concrete itself. Now, we're not talking self-healing, we're just talking strength here. So the carbon in the biochar may form specific bonds with the calcium ions from cement, enhancing the bonds. And the coffee grounds themselves provide silica that can react with the cement minerals during hydration. So the coffee-derived biochar chemically and physically reinforces the cement hydrate binder phase of concrete through a bunch of these different mechanisms. And the biochar integrates and strengthens the concrete's microstructure, which improves mechanical properties like compressive and flexural strength. So really cool way to leverage waste materials into this.
Definitely. And it says here that 100% of the 75,000 tons of waste,
Yeah,
SSG, which I guess is spent
spent
coffee
coffee
grounds
grounds.
produced in Australia, can be utilized in structural concrete. So I have a couple of questions, and you may or may not be able to answer. Because coffee is organic, is it going to decompose? Is this going to last? Though it's
Yeah.
stronger, is it going to degrade the length of time it lasts?
So not being a chemical engineering expert, but just based on the pyrolysis, what they do with the coffee grounds, I don't think so, because they're changing its chemical makeup at the end of the day. So I don't think it's going to decompose. Also, because it mixes in with the cement, and the cement kind of binds to it, so it kind of creates a new blend, if that makes sense.
Yeah, it makes sense. And I really like this idea. We're always talking about how we can use organic or stuff we're already or waste to recycle and reuse anything in our environment to reduce the impact on the environment and climate and whatnot. So we already talked about, do we believe that the 30% stronger limit is a limit, or do we think we can get stronger?
Yeah, so like you said, the 30% increase, it represents the maximum strength improvement they achieved just in their testing. So higher ratios of coffee ground above 5% did not increase the concrete strength any further. In fact, the strength started decreasing again at ratios above 7.5% as too much coffee biochar became detrimental, which indicates that there's an optimal amount of coffee grounds that provides maximum strengthening. So beyond the optimal percentage, the excess coffee ground biochar just takes space and weakens the overall concrete binding. So there's a limit, because there's only so much cement particles that can mix with the biochar. And so if you add too much of the coffee ground biochar, then you have excess that's just going to sit there, kind of thing. And that could potentially degrade, like you were talking about.
And what about look, feel, and even potentially smell of the concrete? Does it look the same?
So it doesn't seem that the concrete made with the coffee grounds looks or feels much different than normal concrete. It doesn't mention any visual differences in the article itself or in my research, but it's probably likely a similar gray color and smooth texture as traditional concrete, because the coffee grounds are charred into a biochar first, so they would not impart their original brown color, if that makes sense. Also, the grounds are finely ground and mixed uniformly, so they're not visibly distinct. So the addition of the biochar may make the concrete slightly more porous, but I don't think it will be able to visually or touch be able to discern the difference. The main difference is more in the mechanical performance, not the aesthetics, if that makes sense.
Yeah, and I guess it's replacing the sand in concrete is this biochar.
I think so. Yeah, I think that's what they're getting at. Or maybe not replacing it, but drastically reducing it. The amount of sand needed.
So I guess the question is, how is it more expensive? Is it less expensive? And what's the environmental impact of creating this biochar? Because you have to heat it up to a certain level.
Yeah. So it does require additional processing steps to pyrolyze the coffee grounds into biochar. So that adds time and energy costs. Now, obviously, the concrete production process, you're going to have to modify to handle the coffee additive. But again, coffee grounds, are not uniformly available in all geographical areas yet. So cost analysis is going to be needed as well for the biochar production and concrete customization. It could be more expensive, but they haven't looked into that yet. The other thing is, can changing the curing behavior complicate the pouring and the setting? They have to look into that too. And then there's potential concerns with odor or volatile organic compounds from the biochar. So it may interfere with the use of other cement additives as well. There's a lot more testing that needs. So there are potential downsides, but again, we're in the early stages. Additional R&D is going to be needed. But this is definitely very promising.
Yeah, and we agree with our watcher. Coffee makes everything better. So even concrete, apparently.
Yeah.
And when will we start seeing this? Does it have to go, like, food intake has to go through FDA or our equivalent process here in Canada for approval?
For sure. Yeah, there's going to be so much because like we don't even know if it degrades yet either. Like we kind of know that the coffee's not going to make it degrade any faster, but there's going to be some testing. So commercialization, we're talking 3 to 5 more years of R&D to optimize the process. And that's if everything goes smoothly. Regulatory approval, building code acceptance are going to require additional time. So based on some of the research, the experts are estimating, again, 10 years from lab concept to widespread commercialization. But I think full-scale adoption, if we're going to get into like our actual infrastructure, highways, bridges, and buildings, we're likely 10 plus years away. But I think niche applications could occur sooner, like within the next 5 years. So if they can come up with, so this would be great in third world countries if they could come up, if the process can be done cheaper, because there's tons of excess coffee in the world, right? So it's just a matter of integrating that. So
yeah, and I don't know where we need stronger concrete personally. I just don't know. Is that going to allow us
bridges, highways, like they're all degrading.
Yeah, okay. They're degrading, but so this does not sound like it's going to solve the degrading issue.
Good point.
Right?
Yeah.
So maybe we leave it a little less material to hold the bridge up. Or maybe we can have stronger things like those barriers to stop cars and stuff. They'll be stronger because we'll make, but I just,
go ahead. Sorry.
No, I'm just trying to imagine in my head where we need stronger concrete. I guess if the concrete's stronger, we can make the walls thinner. We can do a lot of stuff, support more while utilizing less. So
maybe, yeah. Actually, we should do an episode on history tech, on the concrete cement that was done in Greek times back then, because there are specific chemical makeup and specific processes and things like that make that concrete stronger and last longer. Obviously, it doesn't use coffee grounds, but different things like that. There was an article that came out a few years ago that spoke to it as to why these structures that were built thousands of years ago or hundreds of years ago are lasting longer than our more recent kind of structures.
Yeah, I definitely feel we've lost craftsmanship and knowledge at as we go through this. For example, we used to have people who knew what herbs and things would heal you. Now we have pharmaceutical companies who've taken that away, and so we don't have that knowledge anymore. And I'm not, we can go down the road of blaming the pharmaceutical.
TikTok is bringing it back.
But my point being is, because we have Tylenol, we don't go to our natural remedies. It's there. It exists. Why would we? Now, maybe for some of these other things, as the technology moves forward, we lose the knowledge of the what provided those things in the past for those types of things. Like, what made our bridges super strong before? Well, we got concrete now, so we know how to do it, but it's good enough. No one's gone back and say, okay, what did they do here? And how do we apply those processes? And can we make our concrete last 1,000 years now because we're doing this process instead?
Yeah.
All right. So this, any last words on that one, John?
No, this again, coffee makes everything better for sure. This is really cool. I would love to explore at some point the ancient concrete and things like that, and do a follow-up. But yeah, this is really cool.
So this next one, we're talking about the Bionic Bee autonomous flying swarms.
Yeah, scary but cool.
Yeah, they definitely look cool. What's going on here?
Yeah, so Festo has developed the Bionic Bee. So Festo is like, think of them like kind of like 3M. They've got their hands in everything, right? So they've developed the Bionic Bee, which is the world's lightest flying robot at 95 milligrams, and it obviously inspired by bees. It uses ultra thin polyamide film wings that flap at 170 times per second with piezoceramic actuators. So the tiny drone can maneuver dynamically and hover stably, just like real bees. It's remotely controlled via radio and visualizes flight data with augmented reality, which is really cool. Obviously, potential applications are in swarm robotics, automation, inspection, logistics, different things like that. So the wings that are made, it mimics the elasticity and aerodynamics of a bee's wing, which allows the flapping motion. And the piezoceramic actuators vibrate to flap the wings. So these materials expand and contract with voltage changes, which enable the high frequency flapping, which is like, this solves the problem that I was always concerned about, because they've always talked about how we need to mimic nature. We need to like, nature is the best for engineering, but like the wings of these insects and birds, they flap so fast and so complex. How do we replicate that? And it looks like Festo has solved that. So the lightweight carbon fiber body, it integrates the actuators, electronics, sensors, and batteries, and that's what makes it super lightweight. They have sensors on the Bionic Bee. It can measure acceleration, yaw rate, and distance, so it can stabilize flight in real time and enable agile maneuvers. So it's really cool. The augmented reality system uses IR cameras and markers on the drones to visualize its position and orientation in real time as it flies. So really, really, really interesting, cool, new miniaturized tech.
A couple of questions. We're going to see them here, but it's hard to tell. Oh, this one you can see. I guess this is how small they get. That's not all that small.
No, not yet.
And we're watching the video on the Festo site here about the Bionic Bee, and we saw how they transition from over 20 grams down to less than 3 grams of for the shell of the unit.
Yeah.
To get this happen. So how does the flight capability compare to real bees in terms of agility and stability?
Yeah. So for its size, it has impressive flight capabilities, but obviously it falls short of matching the agility and stability of real bees. So the drone's ability to hover in place can rival bees thanks to the rapid wing flapping. And for those of you who are Dune fans, it kind of reminds me of the ornithopter as well.
Yeah.
So, however, the thing with bees is they utilize a variety of different wing motions and configurations to produce diverse maneuvers, including inverted flight, which the Bionic Bee doesn't have that ability yet. Bees can dart and change direction with extreme quickness, which exceed human reflexes. So the drone's response time is slower in comparison. The complex aerodynamics of the bee's wings and jointed body allows them to have superb stability in turbulent conditions. So right now, that drone's ability is challenging. The bees augment lift and control using subtle wing motions and body adjustments. And so the fixed wing bionic bees lack such fine-tuned control. Top speed of bees, didn't know this, can reach 20 miles per hour. But the bionic bee can only reach 5 for now. But again, we're in early stages of this too. So bees have much wider flight envelope for speed, range, altitude, and weight carriage.
So this video seems to be queuing up here, but this looks great. I want to ask, why? First of all, why have a bird-sized bee? What are we, what they're trying to get to, what it can actually do besides camera?
Yeah, so they could monitor crops, they could search disaster sites, they could inspect infrastructure or survey construction sites. Their small size allows them to navigate through extremely cramped or inaccessible areas. Logistic systems could use swarms for rapid last mile delivery in urban environments. So if they scale it up maybe more or use multiple. Redundancy in swarms provide robustness. So failure of individual drones has minimal impact. And also through developing this, they're going to develop their machine learning algorithms, which will allow the swarms to collaborate and make collective decisions, which is kind of scary. So yeah, but there's a lot of potential applications. Yeah.
What do you think the challenges are on scaling this down?
Yeah. Weight. So I think we're gonna have to. So the other thing. So yeah, there's a couple things. So getting it smaller, building the actual frame itself at a smaller scale is going to be difficult. The problem is reducing the weight because you have components like circuits, actuators, and power systems, which bees don't. The lift generation, so they're going to have to redesign the wings and optimize flapping motions, stability. Again, so they have these challenges at the scale right now. So what I think they need to do is they need to achieve a better bionic bee before they scale it down. But even scaling it down, there's going to have to be new technology that comes out, smaller actuators, smaller components, smaller mechanical components, everything like that. A whole bunch of different things. So cost is going to come into play here. How long it can last is definitely going to come into play because obviously it runs off a battery. So,
and what are the swarm capabilities? Like having a bunch of them together, is that going to help, for example, pollinate and help with the bee shortage we're having with props and pollination and whatnot?
It could, but the biggest problem is the short battery life. So apparently it only lasts 3 to 5 minutes. So it would make it difficult for the current bionic bees to pollinate crops efficiently. Obviously, because we know bees can fly for hours continuously. The drones lack the ability to actively collect and distribute pollen, so they have to add something to it as well. Current drones don't have the sensing capabilities to target and pollinate all flowers, whereas bees have specialized sight, smell, and touch to find flowers. And speaking of which, this no mow May is absolutely BS. I think it's stupid. I think it's ridiculous. I don't think it's helping at all, by the way, but that's on a side note. I think it's just creating more allergies, more pollen not more pollen, but it's just creating more problems. But anyways, I digress. So the drones would need to be programmed with the optimal pollination motions and patterns for each specific crop type, which again, not like as we look to these new technologies like self-driving, like you have to start somewhere. So, but there's going to have to be more advances in energy supply, pollen transport methods, weatherproofing, AI pollination programming, and obviously autonomous navigation would be needed.
So I got someone at the door I got to run and check, but I'm going to ask you something and I'll be right back. How close are we seeing these swarms of these drones being deployed in like real commercial applications?
Yeah. So based on the current state of development of this, the technology is obviously in early research and prototyping stage with only basic flight testing completed. So they're going to have to do fundamental improvements in flight time, weather tolerance, autonomous navigation. That's going to be needed to be achieved first. They're going to have to develop machine learning techniques to coordinate the swarm behavior and decision making. That's also still in early phases based on what I've read. The safety, reliability, and collision avoidance must be validated before large public deployments. Again, that's probably going to, it may need more sensors, but they do have the IR on board, so they might be able to use that. Many of the proposed applications like crop pollination, surveillance, and delivery, they're going to require major leaps in capability, specifically flight time. Like 3 to 5 minutes is nothing. It actually could be something for smaller areas, but transitioning from lab prototypes to robust commercial systems could easily take at least 5 to 10 years. Not to mention public acceptance of B-sized drones. So that's going to be cool. So that's going to be challenging as well. So we may see limited pilot deployments of small groups of drones within 5 years for preliminary services, like maybe urban parcel delivery. But widespread, fully autonomous swarms, we're 10 plus years away for sure, easily.
So the whole idea of an autonomous swarm that's controlled by AI or anybody scares the crap out of me for a number of reasons, and we'll get that in a bit. But I wanted to take a look at, like, they got the bionic swift, which is some sort of bird, emotion butterflies, the bionic opter, smart bird, the bionic flying fox, which is like a bat. So
this is great. Oh, go ahead.
No, these are cool.
Yeah, this is great spy technology too, because you're mimicking birds, which and bees too. Like, well, bees is obviously you're going to notice something like the bee, but if you can come up with a bird that looks more like a bird, I think they have submarines that look like dolphins that you can't tell. I think for spy purposes, but again, we could be getting into conspiracy theories.
Well, I mean, it's not conspiracy theories. It's we're going to talk about what this technology could be used for. You talked about the limited battery life. Right now, what are they talking about range-wise for these things?
So I think it's like, I don't know. I think it depends on how fast. So if they can only go, I'm not going to do the math quickly in my head. They can only go 5 miles per hour at 3 to 5 minutes on one charge. So what's that? A few hundred meters, 1,000 meters.
Okay.
Yeah. Not too far.
Okay. And
yeah, but so the recharging time takes 40 to 50 minutes after a full discharge.
Oh, okay. That's a problem because you know your swarm can't go very far. So obviously that has to change for it to be of a real practical use.
Yeah.
But, you know, the idea of a bee or a butterfly or something that size around could definitely be a great spy tool.
Absolutely. Yeah. I think there's a lot of potential applications too. We talked about some of them, but spy technology definitely is one. We'll see if Boeing gets involved. If Boeing gets involved, then they'll have crashing problems. But
yeah, let's not get into that. I just don't have a lot of good things to say right there, and you know. No. But something like the bionic swift looks like it would potentially be able to fly farther just from one, you know, the wingspan and glide and whatnot, or the smart bird, or even the bionic flying fox here.
I'd be curious to see what kind of payloads they could carry.
Well, this becomes the idea of, okay, you know, payload, what could be there, but not also. They don't necessarily have to fly all the way, because we could be delivering these things on the back of other drones that have huge range.
For sure. Yeah.
So
and these could be like kamikaze kind of things where they're birds that are just diving down, right?
They could, if you wanted to. I just think maybe but why not just if you have to deliver a lot of range and you have to send a drone or whatever there anyway, why not just have something on that and have it do that. But there's other reasons to do that. We talk about Russia, how we hear the stories how he poisons his competition. You could definitely do some weird stuff like that with these things if we wanted to get into that. But just the technology is cool. It'd be interesting to see how many. Now, one, is this going to be everybody grabbing one of these and spying on our neighbors with a drone butterfly sitting on the window?
Essentially, yeah. Well, they're using drones right now to spy with the DJI minis and those the FPV ones too. So
oh yeah, those things are pretty small. So I think we're getting into a whole new creepy age, I guess.
Yeah, for sure. Yeah.
I love the concept of these drones. I did read a book ages ago that had the really small insect AI controlled drones, and that was the bad AI took over and whatnot. It was interesting. You have any final words on this and where this is going?
Yeah, this is just going to all those sci-fi movies and things like that you're seeing right now. They're using drones as swarms anyway. So this is just miniaturizing that and maybe more stable, and maybe we're going to get to the ornithopters at some point.
Yeah, and I guess you say one of these things could drop like a regular drone could drop 10 or 100 of these things that dive bomb. And I guess if you're talking about countermeasures and whatnot, having 100 of these things fall versus one is harder to stop.
For sure. Yeah.
So if people are looking for funding for their business, who should they talk to?
Yeah, come talk to me, Shred. I know the deadline's coming up June 30th. If you want to get it in, come talk to me. Come talk to me about any grants. I tend to just to give you guys a heads up. A lot of times I have to play the bad guy, letting you know that there really isn't much out there for you, but happy to explore and kind of let you know what's out in the landscape. But reach me on LinkedIn, John Irwin. If you have any questions, happy to help. If you want to talk automation, reach out as well if you need some automation help.
And you've been talking about this social sunrise.
Yeah, this weekend. So Sunday they actually have for those of you who aren't morning people who are night owls, they actually have a sunset social the night before. So this is going to be interesting to see how tired they are the next day because it's the same people. But this is a great thing. So it's not tech related, but you do breath work, you do mindfulness, you do some yoga, there's some music. It's a great community, very welcoming. There's cold plunge and sauna. So really, really fun, cool stuff to do first thing in the morning on a Sunday.
Yeah, it looks like fun. It looks like fun.
Yeah.
And we've got a few things coming up. It's May 23rd when we're recording this. May 30th is Startup Investor Drinks. We're at, 50 plus people on this one. I just announced yesterday our Collision after party on June 20th. And we're already well over 60 tickets gone for that. It's our biggest event of the year. So you definitely want to go to startupdrinksto.com and you can get tickets to both there. Or links to the Eventbrite, depending on where you want to get them. All our other stuff is on torontostarts.com, the Futuretech podcast. If you're looking for help, if you want to look at Toronto entrepreneur events and whatnot, check out torontostarts.com. And if you're stuck in your business and want to move forward, go to startupcoach.ca, book a discovery call, and we'll see if it makes sense for us to work together.
Absolutely.
You got anything else to talk about, John, before we sign off?
We got some extra time. No, we're good. We actually talked about a lot today, so I'm really excited. Do we want to talk about? No, we're good. Yeah.
Is there something you want to talk about?
No, I was going to talk about what's upcoming, but I don't have it readily available. So
fantastic. All right, John. Thanks, and have a great weekend.
Thanks. You too.
Thanks everyone for watching.